Alright, welcome back, guys. So, we were having this fast API, we were understanding the fast API thing, right? Alright, so let's create this. First, we have to activate the virtual environment, right? So, let's do that first. Right, it will be like uh, like we will activate, right? Now, first we have to create a predictor.py file, okay? So, let's review radar .py. Where you can see there is a predictor.py newly file created, right? So, what this file is about, right? So it will provide just a prediction service for review radar sentiment model for us, okay? So prediction service for review radar sentiment model, right? What it will do, it will load trend artifacts, right? It will do this once only, and it will, after that it will serve the predictions, okay? It will be used by the API, and comma the batch jobs also. So it is about day 33 we will have this, and so tests on day 11, okay? So this is what it will happen, and after that uh, what we have to do, we have to import login first, right? Then import path lib, no, from path library import path, right? We have to do that because we have to access the these models, right? What are the prediction models? Where it are those? In the models folder, right? So we have to access that, so we need that, and then import joblet to save the artifacts. Now what we can do, we have a logger is equal to logging dot get logger, okay? Inside it we will have the object, okay? Now class will be this like sentiment. You know the pydetic we the review yesterday, right? So this is where the class will be. Okay. So this class will wrap the model and vectorizer in it with a clean predict interface. Okay. So we are using class here because and no, we are not using a function here. We are using class because so the model must be loaded once and reused like again and again. Okay. So loading a model from a disk takes some time. So doing it per request would be catastrophic. So a class holds the loaded pair in memory, right? As a state. Okay. Alright, now let's do this thing. If whatever. So that is automatic. We are not using automatic. So self and it will get a model directory also. Okay, of str type equal to which is models. We are setting this as default. Okay, if nothing is passed, then it will consider it as models. Okay, because we know that so it's the constructor. It will run once only when the predictor is created. Okay, so model path is equal to path model directory, right? We are getting it, and after that self dot model. Okay, whatever load, we are loading the model. Okay, from the model path, right, slash senti, because what is the name of our, this is the name, right? Sentiment model, right? Dot joblib. Okay, and we will have this also self dot vectorizer is equal to joblib dot load model path slash vectorizer, right, or joblib. So it will load both the artifacts in a lock and key pair form. Like on day 5 we understand that we have to load, need both, right, model and the vectorizer for successfully predict something, right, unknown things. And self will store them on this object, and it will keep them alive in the memory for future calls. Alright, now logger.info predictor ready. Okay, artifacts from model path. Okay, we can log this information slash. Okay, then after that what we can do, we can define a function that predict which can be like accessed from this class, sentiment predictor class. Okay, and self comma text, which will be string. Dictionary will return dictionary. Okay, and but the whole prediction pipeline for one text is like vectorize, predict, and package the result, right? So we will have this whole prediction pipeline in this predict method. First will be like vectorization, right? So self dot vectorizer we have, because we have gotten this here, right? Vectorizer dot we will transform the text in the vector form, right? We will transform the text. Okay, so we are not fitting that, we are only transforming it that because the model was trained on this vectorizer vocabulary, right? And we are using this list format text because transform expect a list. Okay, so that's why. And we will have prediction is equal to integer of self dot model, right? Dot predict with 0. So what here is usually like model dot predict, we will have a model. That model we are using that model for prediction, or we are given the vector to that, right? Okay, and prediction will be here. Okay, because model is a trained model, right? And it has a predict function also. Okay, so that's why. So this predict will return a numpy array. Okay, so after, when it return a numpy array, so this 0 will grab the single answer and int will convert that answer numpy 64 to a plain Python integer. Okay, but why we are using integer? Because numpy type breaks numpy types breaks JSON conversion later. Okay, so object of type int 64 is not JSON serializable, so it's a write of passage bug, so we dodge it at a source. So what happens, numpy breaks the JSON conversion later. Okay, so object of type int 64 is not JSON serializable. Okay, so in a write of passage bug, we are handling it here, and after this predicts we can get the confidence also from here, right? confidence is equal to float self dot model. We have the model which we loaded, right? Dot predict crowbar with vector vector 0 dot max. So what it will be the sigma confidence from day 5 theory. Okay, float for the same JSON region here, and just a minute. So so why this int is here? Okay, let me explain you, because it's very important in this case. Okay, so when this model predicts something, right, it predicts, this prediction will be in simple language, it will be like this: array of 1, like this, right? Or think of it like this: you can ask it like this: this is the array, okay, array of 1. So even if you ask for one prediction only, scikit-learn always return an array, right? So why 0 is here? So because array has only one element in this, right? This element, right? This one, right? So this is not any element, right? This is empty. So we just want to access this. So to access this element, we are using this 0 here, right? So now prediction 0 becomes 1, okay? But this 1 is not a normal Python integer here. It is wait, this is not normal, it is numpy dot int type 64, okay, instead of just int. So difference between Python int and numpy int is like let's say x is equal to 1, okay. If you find like type of this x, okay, so output will be like this: class int, if you ask this, like. But if you do like this, x is equal to np dot int 64x, if you do this, or like this 1, right, because we are assigning x here. So if you ask type now, okay, so type of x you ask, then it will be like this: class is numpy dot int 64. Okay, so they look identical, this one and x is equal to 1 and 1, but internally they are different objects. Okay, then why does JSON care about it? Okay, suppose you are building a fast API. Okay, like this, your prediction is prediction, whatever you are predicted, right? Like this, where this prediction is equal to this prediction is this np dot int 64, like this, right? The prediction is this. Python convert dictionaries to JSON using the JSON module. Okay, but JSON only understand basic Python types like int, float, string, boolean, list, dict. JSON only understand these. It does not know what numpy dot 60 int 64 is, right? So it throws an object of type 64 is not JSON serializable error. Okay. So what does JSON serializable mean? Means like serializable means here is convert an object into text that can be sent over the internet, right? JSON serializable means we need to convert an object, okay, into text that can be sent over the internet, okay, like this. For example, this one, prediction 1 will become JSON and JSON, like this. Prediction 1. Here it is same, okay. But if Python sees like this, okay, prediction is np.int 64, one like this. It does not know how to convert that special numpy object to JSON, right? So then it crashes. So that's why we are typecasting to the int. Okay. So that is what the case here. Okay. Now, so this is the sigma confidence for the okay. So now what it will return after we can return this dictionary, right? Dictionary will be like this. Sentiment, right, is positive if a prediction prediction is equal to 1, else it's negative. Okay, this is how we can define, and confidence we can do this directly, right? Or we can round it up, round confidence, 4, right? So why we are using dictionary here? Because it's just a clean thing, JSON ready contract, right? So API will barely touch it. So let's just quickly compare this, like test this if it is working or not. Okay, so let me do this. Python C, okay, from review radar dot predictor. Okay, import, right, we have to import something, right? Sentiment predictor. Okay, and is equal to sentiment predictor. We will have the instance here, right, of the class, and after that we will have print of p dot predictor dot predict, right. This product is absolutely wonderful, right. And we can also print like print p dot predict terrible waste of money, like this, right. And we can end this. What is the error? Cannot import sentiment predictor. Oh, whatever. It's not predictor, guys. It's predictor, right? Yeah. So first it's sentiment positive. No, you know, now it's working, guys, right? It's very much working right now. It's very much working. So it's just a quick smoke test without a file here, right? So here this confidence is 9.4 something, and this confidence is 9.8 something, and sentiment is negative, right? Okay. Now now we will build the API itself. Okay, so let's create something here. First we have to create the folder, right? File in source and review radar, right? We have to api.py, right? We have to create this like this. We have this api.py file, right? Now this is a review radar http API, right? The front door to our model, right? We can say that. Now we have to import some common things. Import logging, then we have to import from fast API. We have to import fast API here, and from Pydantic we have to import base model. Okay, field. We will look into it, what is base model and what is field. We are importing. I will just explain. I will explain with all of it to you. Okay, and from review radar dot predictor, right? In review radar we have this predictor, right? Predictor.py, right? We have to import sentiment predictor. Alright, absolute import of our own package, right? Works everywhere thanks to day 6 editable install. So you know what is the editable install we did on the day was reviewed as this, right? So this editable install package, what it is doing for us, whenever we like change anything in this package, right, we can access from here directly. We don't need to repackage that, right? So that's because of this thing. Okay, this build system require backend like this, everything, review radar. This is our package, toy project.tmi. Okay, that's how we did everything, right? Alright, now what we will do is go for this api.py here, and now we will have app equal to fast API. Okay. Okay, before building this, we have to do something. Let me tell you what we have to do. Okay, let me tell you. We have to do the logger equal to logging dot get logger. Okay, now we can build this here. Title is equal to review radar API. Okay, then we will have description is equal to sentiment analysis for customer feedback, right? Like this only, and after that we will have version of this is 1.0, right? Like this. So what is this? What are we building here? Okay, so this is the application object for you. Okay. This is the restaurant itself. Okay, now endpoints will be attached to it, right? So why we need this? Because the metadata, it appears in the auto generated docs. Okay, free professionalism here. So why does we are using name here, right? Suppose your file is this api.py, right? This is, then name is the API. Name is the API, api.py. Okay. So when you do this logger is equal to get logging dot get logger name, right? It will create a logger named API. If another file is model.py, its a logger is model. Okay, so this will help identify which file produced each log message. Okay, that's how. Now why it is app is equal to fast API like this? So what it will do, this will create the main fast API application. Okay, which means think of it as creating a new restaurant. Okay, like before opening the restaurant, nothing exists, right? After you will have a restaurant created, now you can add kitchen, tables, menu, staff, customer, right? So this is the main app. Similarly, after creating an app, you can add the functionalities like endpoints and middleware to it, right? So you need some app first, right? So for that app, you have this title, you have description about the app, right? This is just a instance of the fast API. This is one of the instance of the fast API as we are storing it as app. Okay. Uh, Title is, this gives the your API a name, right? This is the title here. Like you, whenever you open a like HTTP localhost 8000/docs, you will see this. Okay, like auto generated docs for you. Like instead of generic title, everything. Alright. The description is just a short explanation of what the API does, like this, right? Version is like if this tells user which version of the API they are using. Okay. So how this everything will work now? Because client will send a request, right? This request will come to the fast API app. Alright. Then this will handle the request. This will handle request. The request. Then it will use the logger information. Okay. Info request received like this, and then it will run the prediction and return the response. Okay, that's it. As you can see here, right? Now this is the main app. Now what happened? Okay, now we will have the predictor also, right? Predictor will do senti wait here. Okay, predictor is equal to sentiment predictor. We will have an instance of this sentiment predictor class, right? So it will just created once, okay, at startup and at a module variable, right? It will be loaded once. Just a minute. So here we will create the predictor. Okay, so this will create the machine learning model when once the application starts. Okay, this will create that. Think of it like opening a restaurant. Like you have a restaurant open, like chef will arrive, right? Chef arrives, the kitchen is prepared, customer start coming, like this. Okay, so the chef is your model. You don't hire a new chef for every customer, right? So you train the model only once, right? And that model will predict every time, right? So similarly here, application will start and it will load the ML model once, and it will keep it in memory at as a state and use it for every request. Okay. So we are not creating it at every request, right? We are because imagine the model takes 1 second to load, right? Then if 100 users send requests, right? Like user 1 send a request, then it will load a model 1 second, then predict, then it will receive second user 2 request, right? Then again and again. So it is very slow. Good way is like it will start an app and load a model, right? So it will take 1 second, and for every user it will just try to predict from this model, and it will, let's say it is only taking 5 milliseconds, right? So there is a very vast difference. So load once and use forever. Alright. Now this thing is we will have this class review request. Okay. So base model. What is this? So this describes what the client must send. Okay. So think of a hotel receptionist, right? Customer arrive, receptionist ask them, okay, what is your name, what is your phone number, and what is your ID, like this. And if something is missing, like the receptionist say, okay, sorry, you cannot enter in the hotel, right? So that's exactly what base model does here. This base model, right? Okay. It check the incoming data like this. So you remember the pydantic model yesterday we were saying, like that's a base class, so it only get the data which is like like validates, okay, validates the request body. So why we using base model, not data class? Because base model validates at creation, and data class just to hold things, right? So under this, what we will have this, text of string type, right, is equal to field min length is equal to min length is equal to 1, and then it will have max length is equal to 10,000. Okay. In Python it will like this, okay. So what is this saying? This is saying like a request must contain a text of a string type, right? So that string must have at least one character and at most 10,000 characters. Okay. If any there is some empty string or like something like that. So if let's say the input is like this, text is empty string like this, right? So it's a bad request, right? So it will respond with a bad request, right? And it will be rejected automatically. And let's say, but if it is like integer like this, so it also bad request, right? And it will also rejected automatically, right? Okay, so Now next thing is we will have next class is prediction response. Okay, it's also base model. So this is the declared sets of our answer. Okay, like why we declare it? Because we have to declare the response, because fast API documents is guarantees it. So fast API will document it, right, the response, and guarantees it, and the client can rely on it, right? So the contract works both directions, right? So response fast API also guarantees that our response will be in this format only, right? In the base format, base model. So sentiment will be on str format. This plus then confidence. Confidence is also it is float. Alright. This will be our, now what are we doing? App.get okay. So this is a decorator, like whenever we create a app here, right? This is app, our instance of the first API, and this is the method, and this is the endpoint health, right? So this is called a decorator. So what it is doing, it is just registering this function as a handler for get request to the path /health. Okay, this is just registering this the below function. I will type the function as the handler to get the for get request to the path /health. Okay, so what is this decorator doing? It will be when doing registering this function, okay, which is the health function. Okay, so the simplest possible response here. So are we alive or not? Like we are like return what status as okay. That's it. This is boring endpoint matters because load balancers, uptime monitors, and right, like load balancer will check like if the server is alive or not by simple this check. Okay. And on day 18 Kubernetes liveness probes will call this every few seconds forever, and if health stops answering, the Kubernetes restart our container automatically. Okay, so 2 lines today will become the self-healing infrastructure for later. Okay, now this is for app. Now we will have app, this decorator app dot post. Okay, predict, they will give some data for us. Okay, it is using the response model equal to prediction response. Okay, we are using this class. Okay, response model will be like this for us. It will validate that. Okay, it will declare that, and this is the main event for us, right? So this response model will declare like and enforce the answer sheet for us. Okay, this is the decorator for which function? For this function, def predict request of type review request. Okay, this should pass this test also, right? Review request test, and it will prediction response, right? Response, right? So the type int request here, right? Here request is the entire integration here. Okay, so fast API sees it and automatically parses the JSON body, validates it against the bouncer, and rejects the bad input with the detailed 422 and hands us a clean object. Okay, so why this is day 3 payoff? Because 4 days of type hint habits just became automatic here, right? So validation, parsing, documentation, the framework reaches our ends. Alright, in this we will have this logger.info okay, prediction requested a text here, length, right? Then request dot text, right? What, because we have this class, right? With text we have this text field. Well, for text we will have this string, and we are using this validation. Okay, okay, now we just text. Okay, that's it, I think. So we will log the length of not the text here, because user content in logs is a privacy leak, right? We cannot print content in logs, right? So waiting to happen, and log metadata not payloads. So a GDPR flavored habit worth having early, right? And now we will have this result is equal to predictor dot predict request dot text, right? And return predictor prediction response as result. Okay, so what this as two asterisks here, it will unpack the dictionary into keywords. Okay, because this prediction response is what is the result? Predictor predict. This predictor is sentiment predictor. Okay, so this sentiment predictor takes some text and return the dictionary, right? Now this dictionary we have to unpack this, right? So this will unpack dictionary into keyword arguments. Okay, prediction response like sentiment is equal to this, and confidence is equal to this, like that. Okay, and we are constructing the response model here, because one final validation from the owner, our contributor, and this will go into this response base model. Sentiment is this, confidence is this, key value, like this. Okay, all right. So let's launch this fast API for us. Okay, let me show you something very interesting. Fast API. First API dev, because we have fast API, right? Dev src and review radar plus API dot keyword. Starting fast API development. If I go here, okay, if I go here, detail not found, whatever. So what it will do, it will start the development server, which is UV core under the hood, okay, with auto reload. Detail not found, what happened here? Okay, so I think I should restart right. So if I do docs here, okay, as you can see, right? So what is this, our app? Sentimental essay for customer feedback, right? This is the API, right? And get, post, so we can do anything, right? So if I want to get the trial, then it's what is the code is 200, okay. No links here, okay. Let me post something, okay. So it will give us the confidence score. So what to post and how to post here, I don't know. Let me see. So let's try it out, okay. Product is bad as F. Let's execute this, okay. As you can see, the sentiment is negative and confidence is this, right? Content length is 44, content type application initialization, date this, and server UV code. You understand this? What is happening here? Do you understand this, guys? What's happening? Alright guys, so that is we are running this, right? So as you can see, we are fast API dev. Okay, okay, so here, or one other command is here, this you can run it like this, API dev, like file name, okay, api.py, okay, or you can do this like uv core app reload. What is this app? This app.api. You have to load this API. Okay, like this. So this will start your fast API app. Alright. So when this API server app starts, okay, app start, this should be start in a server, right? So what is a server? So think of a server as a computer, or you can say think of a computer as a restaurant. Okay, there is your computer, it's a restaurant, right? So your computer is the fast API server. Okay, okay, so normally your Python program runs once and exit, right? That only runs once, but server is different. Okay, server keeps running, like it waits and waits, right? It waits continuously. Okay? It waits for someone to send a request for it. All right. So when you start this uv core app / API, right? Our file name reload, or this like fast API run, no dev, right, and the file name or file path, right? So these are the commands. If you run any of this command, okay, if you, okay, this is API dev API, okay, so if you run this command or this command, so what it will do, it will start the fast API, then fast API will start the development server. Okay, development server. Development here means like this is the only program while building the application. So this is only for programs while we are building the application. Okay, it is not meant for thousands of users. It is just for when you are building that. Okay, so this is why, because we are calling this development server. All right. What is this UV core? UV core, right? So you can think of this fast API as a safe. API is safe, but safe needs kitchen to build the food, make the food, right? Or you can say fast API is safe, and this UV core you can think of it as a waiter. Alright. So what is the flow here is your customer, and you goes to UV core, right, which is waiter. It's waiting for you. Okay, and it goes to fast API app. Okay, API the safe, like okay, then this you deliver the food. Okay, so fast API knows how to process the request, but UV core knows how to receive requests from internet and give them to fast API. So client gave request to UV core and gives them to fast API. Okay, this is server. Right. And in the command, what is this reload in this command? This says like keep running, right? Suppose your server is running and return the status okay, healthy without reload. Server start test again, very annoying. Okay. So in this server automatically restarts. Okay. Why this only development? Because development server, because imagine 10,000 users are using your website, right? So the server restart every time if file changed. Okay, so user disconnected, website stops and restart, user reconnect like this. Okay, so auto reload is only used while developing. Okay, right. Now after we run this, okay, after we run this, you get this, right? You are getting this documentation at here. It is auto generated. Okay, and this is here, as you can see here. If I do this, let's say, so there is nothing here, right? So details not found. This is just normal message. You can see here server has started, right? And will watch changes in these directories. Okay. So you can see any change happens in this directory, any file changes. If any file changes, so that server will reload automatically. Okay, so UBCon running is in this port. Okay, and so start a reloader using watched files like this, whatever. Okay, now so if this it is saying like UBCon is running. This means this is waiting for server has started successfully. It's now waiting for request, right? And what is this HTTP in this? HTTP is the language used by browser. You can say the protocol, right? And web servers to communicate with each other. It's like saying we will talk like using the HTTP protocol. Okay. And what is this 127.0.0.1, right? What is this? This is the computer itself. Okay. It is also called the local host. Okay, 127.0.0.1. Okay. This is the equivalent of this URL, okay, or the address. Or you can also see, instead of this, you can directly write localhost. Let me show you. Instead of this, you can say localhost. This will also same go to your own computer. Okay. So imagine you send a letter to your own house, right? So it never leaves your building, right? So that's what this localhost means. And what is port 8000? Port 8000 means your computer can run many programs, right? Spotify, VS Code, Fast API, Discord, like this. So how does the computer know which program should receive a request? So it uses the port, right? Think of it like a apartment building. So your computer is building and there are different apartments called 8000, 8080, 5000, 22, 32, like this. So your building is your computer and apartment number is the port. If someone visits this 8000 port, the request goes to the program listed into the port. Okay. Why 8000 specifically? The developers commonly use these ports like 8000, 880, 5000, 3000 for development. Okay. These are the conventional choices. Okay. All right. Now if if I like send okay, what is the health of this? It should return okay. Status is okay means server is running, right? Or you can see like this. Uh, I made a request, right? Get method, and this is the endpoint. Okay, the status is okay. This is the response. All right. So how this process, like first if I received that, right? In this code you can see what is the get. What is, where is the decorator here? My get. So this is the decorator to help. And if it is running, then it will return okay. So that's how it was doing. Okay, status okay. Okay. All right. So let's get there and try some different. We check the health of our health, right? And let's make some different things. Okay. In this. You can access this from this terminal also. Okay, let me show you. Let me make another terminal here. Okay. Okay, so let me curl x post. Okay, http 127.0.0.1, right? 8000 port, and we want to access the predict endpoint, right? Where is the predict? You can see the post method predict, right, is there, right? So we want to access the predict thing, right? And so what will be the content type? Application /JSON, right? And this is the header of the request, right? And we have to make this post like in capital. I think what happened? I think guys I am messed up in here. Let me do something. Okay, so let me go for this. I have to fix this like this, right? I was just saying okay, JSON type, right? And data is this. This is the body of the message, right? This will be of this type, text, like this text, because this is taking the request right? Predict whether taking the request in this form. Request. What is the request form? You can see request is the string review base model, and it is for string, right? Field should be like this. So we have to comply with this base model frame of the request, right? So it has to the identity thing. Okay. And now the text is there. All right. And this product is absolutely fantastic. Let's see. And that's it. This is your thing happened. Let's press enter. What happened? What happened? This product is actually fantastic. What is the problem in this, bro? Okay. What was the problem? So I think we need some space here, right? And here also. Yeah, you can see sentiment is positive, confidence is this. You can see it's working, right? This is our gated like post every. So curl will send the HTTP from the terminal, and okay, and this dash x post is the defining the method. We are using the post method. H is the header. Okay, this header, and this is the path also, right? So post then path, right? Then we have the sets the header telling the server, okay, content type is application./json, right? Body JSON, and d dash d is the body itself. So we need to learn this kernel because it's on every server on earth, right? It is the how you will debug API over SSH also, alright? So it maps one-on-one to the request diagram from the theory, method, header, body, that we have been discussing this point at each. Okay. Expected is this, sentiment is positive, it's already there. So we sent the JSON over HTTP, right? This is the JSON, right? We sent this. A machine learning model ran and structured JSON came back, right? So our request was in this format, right? Field string format, alright, and the request is also in this this format, like sentiment with confidence. You can see sentiment with confidence, right? This is the result, right? This is exactly what happens inside Google Translate, like same shape, smaller scale, right? But it's a real thing. So let's just open one thing here. You are not seeing anything here, right? Just open one thing here, docs. Now you can see I wrote 0 lines for this page, but look, every endpoint listed here, right? Get health is here, post predict is here, right? Predict we have, post predict. Any endpoints you mention, that will be mentioned here, will be shown to you, right? So if I click at predict, okay, and expand it, So there is the request schema with our minimum and maximum rules, right? You can see uh, so text is a string, schema is there, right? All right. Uh, and the response schema, right? This is our input text is like should be this, right? Or description, right? And this is the output of our thing, right? So sentiment string and confidence 0. There is these are just defaults. Okay. Now let's try it now. Let's try it. So if I edit it here, very good feel of product. Let's and I say execute. Okay. And I say execute here. So what you are seeing, you can see this what we are running the term in the terminal is the same here, like right. This is like curl. What this is the terminal we running there, right? Head content type application, add application accept. Okay, like this. So this is the header only. This is the URL, right? And this is the response body, sentiment and confidence. And response header is there, like code content length 44, content type this, right? As we are here, you can see in predict. Okay, we are logging the information, right? Text length like this. Okay, you can see here also in this terminal. I think text length must be there, right? Well, it's not given. Don't worry. Yeah. Here, content length is there. It's already. So this page exists because of our type hints. Okay. 4 days of text, right? We are type hinting here like this. Like this health will be of this type, right? And here you can see request will be in this type, right? And response will be in this type. So whatever type hits we are using from last 4 days, right? So this is becoming the living documentation for us. Okay. So this is /docs. Every FastAPI has it. Okay. Every FastAPI will have it, and when you share an API with a front-end team, okay, this is what you send them. Alright, this is what you send them, like to front-end team. Like this is the API. They will know the all of your endpoints like this, right? You have get, help, post, predict like this. Okay, they will know all the endpoints of yours. Okay. All right, so let's try if bouncer is at work of our or not. Like bouncer, I mean the pydantic bouncer. Okay, let's do this. Curl x. Okay, this is post method, right? HTTP localhost. We can do this, right? 8000. Okay. Predict. Okay. Whatever. Okay, predict dash h, header will be like content, give me a minute, content type application registration, right? And this we delete data is like this, text. And if you are sending some like empty array, right, if it is working or not, we are testing, right? This is null array, so by convention this should reject it, right? What we are saying, the max minimum length should be 1, but we are, the minimum length is 0, right? So if we are sending, let's see, detail type string too short, okay, local bold text, message string should have at least 1 character input, and this is the automatic generated error, okay, from the fast API to us, okay. And you can see here this, let's try it out here, string, make this empty and execute. You see what is the error here? 422 is code, okay, unprocessable entity, okay, like bad request, right? You can see. So here Pydantic rejected the empty string here, right, before our function ran, right? So nothing crashed, just rejection, okay. Why this is beautiful here? Because day 2 we wrote this check by hand, okay, like today we declared it as the framework enforced it with a better error message, okay. And one more thing, what you can do, if you like fill the wrong required field, okay, like this, curl, let me see, x host, right, http localhost 8000 predict, right, and you say like header is wait a minute, content type, right, content type is this application slash JSON, right, and data is this, let's say, because our field is only is this, you can see what is the post thing. This takes the request, okay, but this request must be this predict method. Where is the predict method? It should be the str text field, right? So if we are, this is the text field, but we are setting the review field, right? If we are doing this, good product, like this, right, it will invalid HTTP request received, right? This is the same thing, okay. If same as you can do here, reset it and do this, okay, review, like this. So if you are executing this here, you can see again unprocessable entity, right? Body text, type missing, everything. Alright, so that's how again you hit the error here, and if you like change this to text, what happens? Okay. Okay, so I think I need this. Received by why it is. Okay, so I think this is the problem here. No, okay, why is so clear? Reset, cancel. Okay, wait right now. What is happening to this? If I am entering something here. Okay, so what is the difference here? Let me clear something. I think I made some mistakes here, right? If I like review, then you can say type missing here. Okay, field required input, review DJKV and V. Body text is there, right? Text should be there. So that's how it is saying. So we need error handling also, okay? So bouncer handles the bad inputs, okay? But what if our site breaks? Okay, say the model files are missing or at startup or right now, right? An ugly crash. Let's fail gracefully first, right? Update the predicted. Okay. So I will tell you this tomorrow. Thank you so much, guys, for watching.